students, we were doing vectors. Today we are going to start next topic of vectors, that is component of vectors. Let us start with the questions. Question number 1. Write down the statement. Find the value of x and y. Find the value of x and y so that the vectors 2i plus 3j and vector xi plus yj are equal. Now if any two vectors are equal, suppose we have two vectors a and b, they are equal and components are a1i plus a2j cap, b1i cap plus b2j cap. Since these vectors are equal, therefore I component of vector A should be equal to I component of vector B. Similarly, J component of vector A is equal to J component of vector B. Since these two vectors are equal, therefore I component equal x is equals to 2, J component equal y is equals to 3. Now the next one. Let O be the origin and let P is the point minus 4, 3b in xy plane. Express OP vector in terms of I and J. Also find magnitude of OP vector. O is point of origin, therefore OP vector is position vector of P minus position vector of O. Since O is the origin, therefore 0, 0 minus 4i plus 3j cap. Origin vector 0i plus 0j cap. Therefore OP vector is equals to minus 4i plus 3j. Now we want to find the magnitude of vector OP. That is equals to square root of I component square plus j component square. 4 square 16, 3 plus 3 square is 9, 16 plus 9 25. So magnitude of vector OP is 5 units. Now let us start with the next. Let A vector is equals to I cap plus 2j cap and B vector is equals to 2i cap plus j cap. Is magnitude of vector A is equals to magnitude of vector B, are the vectors A vector and B vector equal? Now what we want to find? Magnitude of A and then magnitude of B. I component 1, J component 2. 1 plus 2 square is 4. Now magnitude of B vector 2 square, I component, J component is 1. 4 plus 1 square root of 5. Therefore, magnitude of vector A is equals to magnitude of vector B. Now the second part is vector A and vector B equal? Two vectors are said to be equal if their I, J and K components are equal. But here the I component has value 1 and I in the B vector has value 2. Therefore, A vector and B vector are not equal vectors because they did not have same components. Because A vector and B vector are not equal because they did not have same components. Or we can say that corresponding components are not equal, therefore vector A and vector B are not equal vectors. Now the next one, question number 4. If the position vector of vector A of point 12n is such that magnitude of vector A is 13, find the value of n. A vector 12 square plus n square. Magnitude of A, we have the value of this, that in 13. Squaring both sides, 12 square 144 plus n square 169. 25 is equals to n square. So n is equals to 5. N is equals to plus minus 5. Now the next one. Find the components along the coordinate axis. Find the components along the coordinate axis of position vector of each of the following points. Find components along the coordinate axis of position vector of each point. Let O be the origin, then OP vector is equals to 5i plus 4j, OQ vector is equals to minus 4i plus 3j, OR vector is equals to 5i minus 7j, OS vector is equals to minus 4i minus 5j. Let O be the origin and position vector of point P, then OP is equals to this. So, after this, right? So, the component of position vector P, component of vector OP is along x-axis is vector of magnitude 5. x-axis के along vector की value कितनी है? Vector of magnitude 5 having its direction along positive direction of x-axis, and y component has value 4 in positive direction of y-axis. Similarly, for OQ vector, it has vector in x-axis, vector has magnitude minus 4, vector has magnitude 4. This sign shows the direction and it is along the negative direction of x-axis, and y component has magnitude 3 and direction is along positive direction of y-axis. Similarly, vector has magnitude 5 in positive direction of x-axis, magnitude 7 in negative direction of y-axis. This is negative direction of x-axis and negative direction of y-axis. Now the next one. Find the scalar and vector component of vector with initial point A 2, 1 and terminal point B minus 5, 7. Now we want to find scalar and vector component. A is the initial point and B is the terminal point. Now position vector of AB is position vector of B minus position vector of A. B is minus 5i plus 7j minus 2i plus j cap. Minus 5 minus 2 plus 7 minus 1. So scalar components minus 7 and 6, and vector component is minus 7i cap plus 6j cap. Scalar components are minus 7 and 6 along OX and OY axis. The vector components are minus 7i and 6j. Next one. If A is equals to 0, 1, B is 0.10, C is 1, 2 and D is 2, 1, prove that AB vector is equals to CD vector. Now we want to find the value of vector AB, that is equals to position vector of B B minus position vector of A. B has I cap plus 0, 0 j cap, 0 I cap plus 1 into j. 1 minus 0, 0 minus 1. So I cap minus j cap. Now CD vector, position vector of D minus position vector of C. D is 2I cap plus j cap, I cap plus 2 j cap. 2 minus 1, I components में से I component minus होगा, j में से j. 2 minus 1 is 1, 1 minus 2. Therefore, AB vector is equals to CD vector. If A vector, B vector are the position vectors of the point 1, minus 1, minus 2, m, find the value of m for which A vector and B vector are collinear. Now we can write A vector as I cap minus j cap, B vector as minus 2I plus m j cap. Now since A vector and B vector are collinear, that is, it is in the same line, therefore A vector is lambda into B vector, where lambda is any scalar. A vector lambda into B vector. Now equate the coefficients. Minus 2 lambda is equals to 1, m lambda is equals to minus 1. From here we get lambda as minus 1 by 2. So we get m as 2. M as 2. Next one. Using vectors show that point A minus 2, 1, B minus 5, minus 1, C 1, 3 are collinear. ABC are collinear, that is, it is in the same line. First find AB vector, position vector of B minus position vector of A. After subtracting minus 5, minus minus plus 2. Minus j minus 2 j cap. Now CD vector, position vector, BC vector, C minus B vector, 1 minus minus plus 5, 6 I cap, plus 3 plus 1. Taking 2 common, 3I plus 2j. If we take negative 2 common, then it becomes minus 2 into minus 3I minus 2j. That is, BC vector is equals to minus 2 times AB vector. BC vector is equals to lambda into other vector. Therefore, ABCR, and B is the common point, ABCR collinear. Therefore, ABCR collinear. If this is the condition, then these two vectors are parallel vectors. Since B is the common point in these two vectors, therefore ABC are collinear vectors. Now next one. Find the coordinates of tip of position vector which is equivalent to AB vector, where the coordinates of A and B are let O be the origin and P be the point. P, X, Y is the required point. Then P is tip of vector OP, that is equals to Xi plus Yj cap, minus origin is 0i plus 0j, that is it remains Xi plus Yj cap. this vector is equivalent to vector AB. AB vector is position vector of B minus position vector of A. 5i cap plus 0j cap, 3i cap plus j cap. 5 minus 3, 2i, 0 minus 1. Now we have given that these two vectors are equivalent. Therefore 2i minus j cap is equals to xi plus y j cap. Since these vectors are equal, so equate the components. X is 2 and y is minus 1, that is the points of tip of if A vector is the position vector whose tip is 1 minus 3, let this point be P. Find the coordinates of point B such that AB vector is A vector if A has coordinate minus 5. Minus 1, 5. Let O be the origin and P is the required point. Then OP vector is I cap minus 3 j cap. Let this is vector A vector. Now let the coordinates of B be xy, then AB vector, position vector of B minus position vector of A, x minus minus plus y minus 5 j cap, x plus 1 I cap plus y minus 5 j cap. Now we have given that AB vector is equals to A vector, that is I minus 3j cap. Equate the components. Minus 3 plus 5, so y is 2, x is 1 minus 1 and x is 0. X component is 0 and y is 2. Let ABCD, if ABCD is the parallelogram and the coordinates of A, B and C are respectively this, find the coordinates of D. Now if ABCD is a parallelogram, then opposite sides are equal. AB vector is equals to DC vector. Let the coordinates of D be x and y, position vector of B minus position vector of A is equals to position vector of C minus position vector of D. Now B has coordinates I plus 4j cap, 2I plus 3j cap, C minus D has x and y. Subtract 1 minus 2, 4 minus 3, 0 minus x, minus 2 minus y. Now these are equal, so equate the components. Minus x is equals to minus 1, so x is 1. Minus 2 minus y is 1. 1 plus 2 is 3. So y is minus 3. So components of D are 1 and minus 3. Now next one. Find a unit vector parallel to the vector minus 3i plus 4j cap. Unit by 5 I cap plus 4 by 5 j cap. Next one. Find a vector of magnitude 5 units which is parallel to vector 2i minus 4 j cap. Vector has magnitude 5 unit which is parallel to vector this. Let this vector as a vector. Unit vector parallel to this is a vector upon magnitude of a 2i minus j cap. Magnitude of vector is 2 square plus minus 1 square 4 plus 1, that is square root of 5. Now since this vector has magnitude 5 units, therefore the required vector is 5 into a cap 5 into 2i minus j cap upon square root of 5. 5 upon square root of 5 is square root of 5 into 2i cap minus j cap. Now the next one, question number 14. Find a vector 15. Write all the unit vectors in xy plane. Write all unit vectors in xy plane. Let r is equals to r vector xi plus yj cap is the unit vector in xy plane. Then magnitude of r is 1. Squaring both sides we get x square plus y square is equals to 1. Now x is equals to OL cos of theta. X is equals to OL cos theta is OL upon OP and sin theta, sin is P upon H. Since this is unit vector, so r vector is equals to x is cos theta I cap plus sin theta j cap. Since OP is x, so x is this cos theta I cap plus sin theta j cap. Theta varies from 0 to 2 pi and it is the equation of circle x square plus y square plus 1 in clockwise. So this covers all possible directions of vector r. Write down a unit vector in xy plane making an angle of 30 degree with the positive direction of x-axis. Pxy with a point in xy plane, so OP is 1. OP, इस क्वेश्चन में भी OP की वैल्यू 1 थी because it is a unit vector given. X is cos 30 and y is sin 30. 30 degree. From previous example, you can see that. So x is cos 30 is square root of 3 by 2 and y is 1 by 2. Therefore, OP vector is square root of 3 by 2 I cap plus 1 by 2 j cap. These are the questions related to component of vectors in two-dimensional. Now we will start questions related to component of vectors in three-dimensional.